All right, welcome back to the Punny Math Teacher, because I can remember what I'm doing. All right, so let's stay on track. Make sure we have twice this video's length to take notes and wonder. I am going to try to skim this a little bit because we're just doing square root properties, so it's only 4 examples, and it should be much faster than the 20-minute video that you just watched for the last lesson. All right, so remember, we are going over square root properties, so we are starting to solve quadratics. So you've already solved by graphing. Remember, that is on page 45. So if you want to go back to page 45 and look at what does solving mean, we're going to solve also using the square root property. And that's another method in our toolbox that we can use. So without further ado, back of our table of contents, we are now on solving quadratics by square root property, page 48. And the rest of it is pretty much just solving. 48. All right, so make big 4 boxes. So the top 2 will be for notes and notes, and the bottom 2 are for examples 1 and examples 2. Example 1A and B. There actually is 2 over here. And example 1B. If you want to label those ahead of time, you are welcome to. So we are going to be solving equations like this. Like this, and like this. We're also going to learn more methods to solve things like this, but the square root property is one tool that we can use for these patterns. So, what are the answers to? Okay, so if I asked for the square root of 4, you can give me a positive 2, because 2 multiplied by 2 does get us 4. Notice I'm using parentheses or multiplication. We're not using the X or an asterisk. Sometimes you can, but parentheses are much clearer for that. And you could also have given me a negative 2, because note that a negative 2 squared also equals a positive 4. You could write this as positive 2 squared, or put the negative with it in the parentheses. So if negative 2 is being squared, the negative is with the 2 in the parentheses. All right? So we would write square root of 4 equals plus or minus 2, and notice there's a plus or minus symbol. It's literally how we say it, is plus or minus. Now, I do want to do a random aside. So if you were going to graph x squared, that function looks like this. It is a function because if we go through the vertical line test, it only passes through our graph 1 time. So if I graph the square root of x, I'm only going to get this part of the parabola is going to get reflected. That's the only part that's going to be, or actually, it's this part. This part is the only one that's going to get reflected because it's a positive square root. If I, for instance, decide to graph plus and minus, I'm going to end up with this, which is cool because then we can see the parabola, it's reflected, it's a great inverse, but it's no longer a function because when I do the vertical line test, it's going to cross my graph at more than one location, at least one spot, because it hits once there, but the rest is all going to be 2. And that means it's no longer a function. So when we work with functions, which is pretty often, we're going to say the square root is only a positive value so that we can keep that relation as a function. So in the last couple pages when I said the square root of 25 is 5, that's correct because we're thinking of it just as the positive part for the function. But if I wanted all square roots possible, you are going to have a plus or minus. So we do have to think about that as a possibility as we solve these equations because there's another value of x that's possible. So even if I'd say square root of 4, just give me 2, okay? But if there's an x involved, we're going to have to work with a plus or minus symbol. So our steps for today are going to be use the square root property when in form ax squared equals c, or x plus or minus number squared equals c. So if you see an equation that's in this form where there's a coefficient x is squared and it equals some constant, then you're great. Use the square root property. or if we have x plus or minus some number squared equals c. That's awesome. This is going to be called a factor. The x plus a number or x minus the number is called a factor. And yeah, so these are 3 different examples of those formats. Notice that A and C are from that standard form. So if you want to go back to your quadratics notes from before and find standard form and see how those relate and where B went, then you can go look at that. So our steps are going to be to divide by A on both sides. So the goal is to get the x squared or the factor, isolated. We're trying to get that squared quantity by itself, okay? And then we're going to take the square root on both sides. Notice that I'm saying squirt because that is the computer code. So if you want to type a square root into Desmos, make sure you're typing SQRT and it'll pop up for you. It also works in Microsoft Word. And the goal here is to get the x isolated. And remember to use your plus or minus symbol. All right, so we're going to follow these steps in our following examples. So on here I have an a, x squared equals c. So I'm going to divide by the a on both sides. Notice that this is going to leave us with just x squared. Something squared all by itself equals something else. Now I'm going to undo that square by square rooting. And now when I do this, I do have, oh, wow, my notes are wrong. So the square root of x squared, we've already talked about, that's just x because those are inverses, they undo each other. But for my final answer, you do have to stick that plus or minus on the front of your radical sign. And that's it. X would be this plus or minus the square root of 5. So if I substitute that in, I'm going to end up with a positive 15 no matter what. All right, example 1b. So I need to get the x squared by itself. So I should be able to divide by 5, woohoo! But like a normal equation, I'm going to actually add this 180 and eliminate that 180 first. So I'm going to end up with 5x squared equals 180. Now it's in the form that we had example 1a in. Now that I've got that constant moved over, I just have a coefficient, so I can divide by that coefficient. Keep that x squared on there. 5 goes into 120 times, 5 goes into 80 16 times, so it is 36. And then I'm going to square root both sides. Again, the square root of x squared will just be x because they are inverses, they just undo each other. And this is now a plus or minus 6 because we actually do know the square root of 36. So if you can simplify this, go back to page 46, follow those simplifying instructions, and you're going to simplify them. Since 5 was prime, it's left as it is. 36, I actually know it, it's a perfect square, so it's going to end up being a 6, plus or minus. All right. And then, which you can actually test. If you want to plug that 6 back in as x, see what happens. What is 6 squared times 5 minus 180? What is negative 6 squared times 5 minus 180? And you should end up with 0 both times. All right, example 2, we have a coefficient. We have a quantity squared. So I'm going to divide by that 4 because these make 1. And that's what our goal here was to get all of these to make 1. So the x squared quantity is all by itself. I'm going to end up with x plus 2 quantity squared equals 25 because I can simplify that. And then since I have the quantity squared isolated, what's next? I'm going to take the square root on both sides. So I'm going to end up with x plus 2 because it's the whole quantity because the square root and the square are inverses, but the x plus 2 is left alone equals, and then it's plus or minus 5. Now, because I have a plus or minus, I do have 2 options. We saw this before on page 47 with our operations with radicals. I'm actually going to split this up. I'm going to get one that says x plus 2 equals positive 5, and another equation that says x plus 2 equals a negative 5. So I've done all this shared work. Now I'm going to split it so I can actually solve it. I'm going to eliminate the 2 on the left-hand side, so x equals 3. I'm going to eliminate the 2 on the left-hand side, so x equals negative 7. You could box these, or you could write them together. Both ways are appropriate. All right, we found x. Now go back to your graphing quadratics, solve quadratics by graphing, and see what do these x's all represent on a graph. Why would they be helpful to know, and why do we even want to use this? Why is this strategy better than graphing? And I want you to go get, there we go. So, comprehension questions, why are x-intercepts such a big deal? And then start thinking about your brochure or how-to wiki type blog for how you would factor. That's going to be coming up next. And then choose your own adventure flowchart for which method you would use to solve. You've learned two, graphing and square root properties. So which method do you prefer? And which examples are best solved by graphing and which are best solved by square root property? Could you make your own? All right. Thank you for watching and have a great day. Bye.